Okay, section 3.1, we're going to go over graphing parabolas and finding the domain and range. There are a few different forms that the quadratic formula is going to be written. We're going to start by going over those. The first one is standard form. So standard form is when you're going to have three terms, an x squared, an x, and then your constant. With your standard form, there's two things that you will need to know how to do. The first one is how to find your axis of symmetry. Your axis of symmetry is going to be the line that cuts your parabola in half, and your parabola is going to be symmetrical on each side of that. It's always going to be an x equals equation, and when it's in standard form, the way we figure out what it's equal to is your negative b over 2a. The axis of symmetry value is also going to help you find your vertex. Your vertex is going to be a coordinate point. It has the same x value as your axis of symmetry, so negative b over 2a. And then to figure out what the y value is, you're just going to plug that into the equation and solve for y. And that will give you your coordinate point of your vertex. Our second form is vertex form. This one is a little bit easier. There's no math involved in finding your axis of symmetry and your vertex. Your axis of symmetry is going to be equal to whatever your h value is in this equation. And one thing, just like our absolute value functions, when you take h out of the equation, it's going to be the opposite sign. So if it's negative in the equation, it becomes positive. If it's positive in the equation, it becomes negative. That will also help us with our vertex. So our vertex, just like with our absolute value functions, is going to be h and k, where h is the opposite sign and k is the positive sign. Now, your vertex of your graph, and this is true for your standard form, vertex form, and your intercept form, what your vertex is doing is moving your graph left and right and up and down. And it's really obvious in your vertex form what each of these parts is doing to it. So when your h value is positive, that is going to move your graph to the right. So if we add anything to that h value, it moves it to the right. When we subtract or take anything or have a negative value for h, that's going to move it to the left. Then for our k values, if we have a positive k or we add something to our k, that is going to move our graph up. If we subtract anything or have a negative k value, that is going to move our graph down. Then our last form is our intercept form. So your intercept form, that is going to show you where your graph is intercepting the x-axis. And to find your axis of symmetry for this one, your x value is going to be equal to p plus q divided by 2. That's going to tell you where your axis of symmetry is. And just like with standard form, that is going to give us the x-coordinate for our vertex. So you take p plus q and divide by 2. You plug that into your equation, and that will give you your y value. One thing to make sure you're paying close attention to is because it's minus p minus q, when you take those values out of your equation, those are going to be opposite signs. So if they're positive in the equation, they'll be negative when you find your axis of symmetry. Same thing, if they're negative, they'll become positive when you find your axis of symmetry. Okay. One thing to note, all three of these graphs or forms have an a value. And with your a value, that is going to affect your graph just like it did with our absolute value. If a is a positive number, your graph is going to open up. If a is a negative value, your graph is going to open down. And then the absolute value, so not looking at the positive or the negative of the a value, just looking at what the value is or how far away from 0 it is. If that number is less than 1, your graph is going to get wider than normal. And if that absolute value of a is greater than 1, it's going to get narrower. And the reason is because when it's a fraction, so it's less than 1, you're going up only a little bit, but you're going to go over a lot more. And it's the opposite when a is greater than 1, you're going to go up a lot, but over only a little bit. So your graph is going to end up being narrower or skinny when you look at it. Okay, so now that we have all of that information, hopefully some of this is review from Algebra 1, we're going to move on to looking at characteristics of an equation. So we have a function f of x equals x minus 5 in parentheses squared plus 8. We're going to use that to write new equations that have the following characteristics. The first thing I would like you to do when you have a problem like this is first write down what your old vertex is. And that is going to be coming from the equation that they have written down here. So your h and your k. Don't forget your h value is the opposite sign when you take it out of the equation. So it becomes positive 5 and positive 8. Once you have the old vertex written down, read through the problem and see what we need to change about the equation. The first thing is that we need a wider parabola. And when it's wider, your a value has to be less than 1. Your parabola is also moving right 6. So your h value is what moves your graph left and right. So we're going to take that h value and we're going to move it right 6 or plus 6. So we're going to add 6 to that h. Then we need to move down 3. K is the value that moves your graph up and down. To go down, we need to subtract. So now we know everything that we need to change about our equation. So before we start writing it, we need to find our new vertex. This is the one we're going to use to write our equation. So we know we need to add 6 to our h and then take away 3 from our k. That gives us the new vertex of 11, 5. These are our new h and k values that we're going to plug into our equation. Your a value might be different than someone else's, but your a value just needs to have an absolute value less than 1. So any fraction less than 1, that 1/2, 1/3, 1/4, 2/3, all of those will be counted correct for your a value. So you can write f of x equals, or y equals, let's use 1/2 this time. And again, if you chose a different fraction, that is okay. And then we would have x minus 11 in parentheses squared plus 5. So the last part of this equation needs to be the same for everyone. The only part that might be a little bit different is this a value in front. Everything else needs to be the same. Okay. Now if we look at our second part, we're still using that same original function. So our old vertex is going to be the same as it was before, with 5, 8. This time, we need to change the graph to be narrower, so our a value, the absolute value of that, has to be greater than, a 1, greater than 1. We're going to move left 3, so our h value, we're going to take 3 away, and up 2. Okay, we're going to add 2. Now that we know that, we can go ahead and find our new vertex. So we need to subtract 3 from our h and add 2 to the k value. Once we have that, 5 minus 3 is 2, 8 plus 2 is 10. That gives us, again, our new h and k value. Your a value might be different. It just needs to have an absolute value greater than 1. So with our function, I'm going to choose the number 2. And then in parentheses, everyone should have x minus 2 squared plus 10. So the only part that might be different from person to person is this a value up front. Okay, the next thing we need to know is the difference between real roots and imaginary roots. For today, the only thing that you need to know between these two is what it's going to look like on a graph. So for real roots, there's going to be the option for 1 real root and 2 real roots. An example of when you would have 1 real root is when you have a coordinate plane and the vertex of your parabola is going to be on the x-axis. So when we're asked about roots, roots are going to be where it is crossing the x-axis. So then when we have two real roots, you're going to have, again, your coordinate plane. Except this time, instead of passing through once, it's going to pass through twice. And that's going to give us two real roots for our parabola. And again, your roots are the x value of where it crosses the x-axis. Okay, so now before, when you would be solving for x in Algebra 1, you would solve for these real roots. And if you found that it was not possible to find a real root, you would write no solution. We're now going to be adding what we call imaginary numbers and using those to find some more solutions for our problems that might not be a real number, but they are imaginary. We're going to go over that in more depth later. For now, we just need to know how to identify if a graph has real or imaginary. Imaginary roots are going to be when your graph never crosses that x-axis. So it's either going to be above like this one or below. And when that happens, you are going to have imaginary roots. And we're going to go in more detail of how to find those next week.